This section is about rectangles, and you will learn how to find the area of a rectangle when given its perimeter and either the length or width. You will learn to find the area of irregularly shaped regions containing rectangles, and you will learn to find the lengths of diagonals of rectangles. Here are the most important formulas for rectangles and some other important facts as well. The formula for the perimeter, P, is P equals 2L plus 2W, where L equals the length of the rectangle and W equals the width. The formula for the area A is A equals L times W, where L and W are the length and the width. It's good to know that the measure of each of the four angles in a rectangle is 90 degrees. The diagonals of the rectangle are congruent, and because a rectangle is a special case of a parallelogram, the diagonals bisect each other. Example 1. The perimeter of a rectangle is 300. The length is 50. What is the area of the rectangle? Step 1 is to use the perimeter formula to find the width. P equals 2L plus 2W. We replace P with 300, and we replace L with 50. This gives us 300 equals 2 times 50 plus 2W. Doing the math gives us 300 equals 100 plus 2W. Next, subtract 100 from both sides. This gives a result of 200 equals 2W. Divide by 2 and find that W equals 3. Next, substitute the length and width into the formula. A equals L times W. The length is 50. The width is 100. Multiplying gives us the area of this rectangle is 50 times 100, or 5,000 square units. In example 2, find the area of the shaded region. We don't have a formula for something that looks like the shaded region, but we notice that we have a square on the inside and a rectangle on the outside, and we can subtract the area of the square from the area of the rectangle to get the area of the shaded region. The area of the rectangle is length times width, and we're told its dimensions are 5 times 3, hence it's 15. The area of the square is its side length squared. We're told that it's x, hence the area is x squared, and the area of the shaded region is 15 minus x squared. In example 3, the length of a rectangle is 1 less than twice the width. The perimeter is 40. Find the area. Your first step is to find an expression for the length in terms of the width. Because the length is 1 less than twice the width, this is like having twice the width and subtracting 1. Therefore, L equals 2W minus 1. We substitute into the perimeter formula P equals 2L plus 2W. We replace L with what L is equal to, which is 2W minus 1. At this point, we have 40 equals 2 times parentheses 2W minus 1, close parentheses, plus 2W. Notice that at this point, we have only one variable in the equation, which is W. We proceed to solve for W. Distributing gives us 40 equals 4W minus 2 plus 2W. Combining like terms gives 40 equals 6W minus 2. We add 2 to both sides, 42 equals 6W. Dividing both sides by 6 gives W equals 7. We now substitute to find the numerical measure of the length. Recall that the length is 2W minus 1 and that W equals 7. Hence the length is 2 times 7 minus 1, which is 14 minus 1, which is 13. Now we substitute into the area formula length times width. The length is 13, the width is 7, that product is 91, the area is 91 square units. In sample 4, find the length of CE. This is the slide that teaches you how to find the diagonal of a rectangle. Because the corner angles are all right angles, we can use the Pythagorean theorem, a squared plus b squared equals c squared. Therefore, 3 squared plus 4 squared equals c squared, 9 plus 16 equals c squared, 25 equals c squared. Taking the square root of both sides gives us 5 equals c. That's the length of the entire diagonal AC. However, we're only asked for CE. Recall the fact that the diagonals of a rectangle bisect each other. Hence, the diagonal DB cuts AC in half. CE will be equal to AE. Because the full diagonal is 5, half of that diagonal, or CE, must be half of 5, which is 2.5. Example 5. A rectangle has length L and width W. The length and the width are both doubled. What is the ratio of the area of the larger rectangle to the area of the smaller rectangle? Notice what's in bold on the left. Avoid the common mistake of thinking that since the length and width are doubled, that the area must be doubled. In fact, the area increases by a factor of 4. And on the right, we explain why that's the case. The area of a smaller rectangle is L times W. The area of the larger rectangle is 2L times 2W. When we combine like terms, we have 2 times 2 times L times W, which is 4LW. Now we form a ratio. Because they're asked for the ratio of the larger rectangle to the smaller rectangle, the fraction is 4LW over LW. The LW's cancel, and we have 4 over 1, or 4:1, 4 to 1. Here's example 6. A gardener has 900 feet of fencing and wants to enclose a garden. He can either form a rectangular garden with dimensions of 300 by 150 feet, or he can form a square garden. Which dimensions will enclose more area? Let's just do this by plugging and chugging. If he multiplies the length and the width of the rectangular garden, that's 300 times 150 equals 45,000 square feet. However, if he decides to form a square garden, each side will be 225 feet, and finding the area of the square is 225 times 225, which is 50,625. The square will give a larger area. Here's an important little tip for the SAT. If you are using fencing for all 4 sides of a quadrilateral, the square will give you more area. However, if you are using fencing for 3 sides of a quadrilateral and a river or some other pre-existing barrier as the 4th side, the answer is different. This topic will be explored in more detail in the section on quadratic word problems. Here are some practice problems for you to try. Pause the DVD after each problem, and when you're finished, come back for the answer. Practice problem 1. Given the rectangle and square in the figure below, find the area of the cross-hatched region. The area of the rectangle, recall, is length times width. The area of the square is z squared because the figure tells us that its side length is z. The area of the shaded region equals the area of the rectangle minus the area of the square, and that's LW minus z squared. Just as a reminder, the SAT will frequently ask you to solve these kinds of problems using variables instead of numbers. They're trying to test that you understand the algebraic and geometric concepts involved and aren't just relying on your number sense. So pay special attention to these problems with variables. Given the 2 rectangles below, find the area of the shaded region. Notice that the dimensions of the larger rectangle are 8 and 5, while the dimensions of the smaller rectangle are 3 and 2. The area of the larger rectangle is 8 times 5, which is 40 square units. The area of the smaller rectangle is 3 times 2, or 6 square units. The area of the shaded region is 40 minus 6, which is 34. Practice problem 3. The length of a rectangle is 5 times its width. The perimeter is 36. Find the area. The answer is 45. Step 1 is to find expressions for the length and width. The width equals W. We're told that the length is 5 times the width, or 5W. Now we substitute into the perimeter formula. This gives us 36 equals 2 times 5W plus 2W. 36 equals 10W plus 2W. 36 equals 12W. And dividing by 12 tells us that W equals 3. Now we find the length. The length is 5W, and since W equals 3, the length is 5 times 3, or 15. Now substitute the length and width into the area formula. The area is 15 times 3, or 45. The width of a rectangle is 1/2 its length. The perimeter is 12. Find the area. Here is the answer to practice problem 4. The answer is 8. Step 1 is to find expressions for the length and width. The length is just labeled L. Remember, the width is half the length, and therefore it becomes 1/2 L. Step 2 is to substitute into the perimeter formula and solve for L. P equals 2L plus 2W. 12 equals 2L plus 2 times 1/2 L. This gives us 12 equals 2L plus L, or 12 equals 3L. Dividing both sides by 3 gives L equals 4. Next, we substitute to find W. Since L equals 4 and W equals 1/2 of L, W equals 1/2 of 4, or 2. Next, substitute into the area formula. A equals length times width. That's 4 times 2, which is 8 square units. And here's practice problem 5. We want to find the length of CE plus DE. The answer is 5. By the Pythagorean theorem, both AD and BC equal 5. Since the diagonals are congruent and bisect each other, both CE and DE are equal to 2.5. Hence, their sum is 5. Practice problem 6. Charlie has 32 feet of wire fencing with which to make a rabbit hutch. He can make the hutch with dimensions of 10 by 6, or he can make a square hutch. Which design will give the rabbit more space? The answer to practice problem 6 is the square hutch has more area and hence more living space for the rabbit. Practice problem 7. A playground for a nursery school must have 1,600 square feet of area. The contractor considers 2 designs. The first measures 80 by 20. The second is a square. Which design uses the least amount of fencing? The answer to practice problem 7 is that the square will use less fencing. If the contractor builds a rectangular playground, the perimeter, which indicates how much fencing he will use, will equal 2 times 80 plus 2 times 20, which equals 160 plus 40, which is 200 feet of fencing. However, using a square, the perimeter and thus the amount of fencing will equal 4 times 40, which is 160 feet of fencing. Notice that using a square will use the least amount of fencing for a given area. Again, that's assuming that all 4 sides are bordered by fencing and not some other natural boundary on one side. Practice problem 8. A rectangle has length L and width W. In another rectangle, the length and width are both 4 times larger than they are in the original rectangle. What is the ratio of the area of the smaller rectangle to that of the larger rectangle? The answer to practice problem 8 is 1/16. The area of the smaller rectangle, A, equals L times W. The area of the larger rectangle equals 4L times 4W, which is 16LW. The ratio of the areas of the smaller and larger rectangles is LW over 16 LW, and that reduces to 1 over 16.